Hello and welcome to the Buildmore podcast. I'm your host, Juan Antonio, and today we are going to be interviewing the team from Dynamic Carbon Credits. Now, Dynamic Carbon Credits obviously sells carbon credits, but those carbon credits are generated by a very cool direct air capture process that involves genetically modified plants taking carbon out of the air, sequestering it deep in the soil. A mix of microbes is used to break down the carbon in the form of sugars that is deposited into the soil, and then the plants themselves at the end of their growth cycle, because they take in the most carbon while they're growing, at the end of that cycle they are turned into things like hempcrete or biochar, which can be used to amend soil to improve quality and fertility, or it can be used as an additive in construction materials. There's a whole lot of uses for this biochar. And what's really cool about this approach is that instead of complaining or demanding regulation or defacing, valuable works of art or whatever it is that other people are doing to combat climate change, Dynamic Carbon Credits is using science and ingenuity and putting their own money on the line to try to solve this problem. And of course, they're benefiting from the incentives in the voluntary carbon credit market. But again, it's a voluntary market. This is not a carbon market that operates on a cap and trade system like in the EU. They are using voluntary transactions to fund this. And at the end of the day, this is the kind of approach that I think we need if we want to combat issues with the ecosystem, with the climate. We need a science forward, a solutions forward approach, and less finger pointing, less deceleration, and less demands for degrowth. At the end of the day, we want to continue to grow. We want to continue to improve our quality of life. We don't want to take that away, but we do want to mitigate the potential risks of climate change. And I think that the way DCC is doing it is fantastic. So today I'm going to be interviewing the CEO of DCC, that's Beau Parmenter, the lead scientist, Anna Jacobs, and the business executive, Emily Dakoske. And I hope you enjoy those interviews. All right. Hello, Beau Parmenter, the CEO of Dynamic Carbon Credits. Welcome. I wanted to do this interview with you because I think that the solutions at Dynamic Carbon Credits are helping the planet, and they are aligning with something that I believe in a lot, which is this sort of techno-capital acceleration, this ability for humanity to keep growing and adding to our technological repertoire without continuing to damage the ecosystem and the climate. And so I think the solution-focused aspect of Dynamic Carbon Credits is something that's really attractive to me. I want to start with a little bit of background so that the listeners get to know who you are, Beau. So could you tell me, I know you are also the CEO of Elite Group, and you have some background in construction and in agriculture. So maybe if you could give me a little bit of background here, give us a little bit of background on who you are and how you got to where you are today.
Thank you, Juan. It's a pleasure as always. I got to where I am today. We've had an excavation, demolition, and concrete company for 24, almost 25 years, and that got pretty heavy into the environmental cleanup side. And I was noticing a common trend of a lot of the environmental companies were running a policy of dilution is the solution, and it's just kind of the philosophies of how they've learned how to deal with such problems and environmental issues rather than actually dive right into it and figure out how to fix it. They're just going off what they were taught and how they've handled it for the last hundreds of years, and nothing has really changed. So I sought out a solution to, hey, how can we actually change this and move stuff in the right direction? So, for instance, on the environmental side, most stuff was too acidic. They would dilute it with sodium bicarbonate and run it down till the top numbers were palatable and passing on testing, and that's where they would quit. And we took it a step further and we got into a lot of phytoremediation. So we were using plants and plant energy and their natural mechanisms to be able to clean up the soil and clean up contaminants and make the world a better place, and let them do the work and let them hold it within the plants and store it within the plants. And by doing that, we were able to not only be more effective, a lot lower risk of any contamination, risk going back into different waterfors and wells and different things of that statute, as you would if you were actually pumping it out of the soil, and all the different attributes and risks that come with that. We were able to eliminate a lot of those. So when the carbon credits started coming down the pipeline in the 17 and 18, when everybody started talking about that, we started doing some digging into what we could capture with our plants and where we were with phytoremediation and whatnot. And we realized that we were actually very successful at capturing it where we currently were, but not to the statute of what the land would go for per acre. So we sought out at that point to how can we capture that? How can we utilize as much of the acreage as possible to capture as much carbon as possible? So we started breeding some of the top plants and really started seeing tremendous results. So that's what really gave us our vision, being able to see that, hey, we can do this, and we can do this really at a unheard of level.
So you mentioned that the this sort of prevailing viewpoint in the industry before you brought your solutions forward was dilution as a solution, and I'm presuming from what you said that that means that they would use other chemicals to offset imbalances in the pH. Could you talk a little more about how the difference between that approach and the approach that dynamic carbon credits started using?
Yeah, so the big difference in that is they would be temporarily putting a band aid on it, because often the problem is still there. It's just not on the top side where you're seeing it. And with what we're doing is we're hitting the top and all the sides and depths of it to really capture it, pull it away, and most often, but not always, depending on what it is we're capturing, digest it. So actually permanently break it down, convert it into something that's palatable and goes back into the earth naturally where it originally came from. And that's really what it's all about, rather than trying to figure out how you can capture it and pump it into these wells and then worry about it, these wells going to leak out, and all the different problems and attributes that come with different older methods of doing such things, similar to what they do with a lot of different contaminants that they've done in wells and geological storage and so on and so forth. And then, of course, then you have to worry about, with fracking going on, different things, is that leaching into water wells and waterways and water aquifers and all of those different attributes as well.
So your solution, or dynamic carbon credit solution, is not only effective, but it is helping preserve things like the water supply, the pH balance therein, and also it's capturing carbon. On the subject of capturing carbon, I noticed that dynamic carbon credits, although there are states in the U.S. and there are places that dynamic carbon credits can do business with that are in these sort of regulatory cap and trade markets, the primary avenue seems to be the voluntary carbon credit market, which I find very interesting. And I think that voluntary exchange is sort of the basis of definitely American enterprise and of free enterprise everywhere. So can you tell me if that was a preference, if that was just what happened to be coming down the pipeline, and maybe what your thoughts are on the differences in the dynamics between voluntary carbon credit markets and cap and trade markets, particularly in the current environment where voluntary carbon credit markets seem to be a lot smaller but seem to be growing faster than the cap and trade markets.
So yeah, it's definitely, it started out smaller. I would say it's definitely greatly exceeded now at this point. And I would say the big reasoning behind it is a lot of the greenwashing has come out with the bad credits.
Hmm.
And with cap and trade, there's not enough money in the credits to be able to actually go out there and capture carbon and permanently store it away. The numbers don't make sense, and somebody couldn't logically do it in the way it's supposed to be done and be able to store it away for hundreds, if not thousands, of years. So that was why we didn't go in the cap and trade market, just because we couldn't really do the right thing and be able to do what needed to be done.
Right.
Furthermore, the cap and trade market does not have hardly any regulations behind it compared to what most of the companies are requiring and going through for the voluntary side. So the companies and enterprises are basically writing their own. And that's why so many of the companies have switched and went to the voluntary side so that they can write their own bylaws for it, which greatly needed to be done just because the cap and trade missed the target on that so much. They were more
Oh,
focused on the price of them and controlling that and controlling the market share than they were controlling quality control and making sure that they actually had real valid credits and that they were really permanently being stored away.
that's interesting. That's something I didn't know, that because I would have thought that the cap and trade markets would have had the quality control stuff down pat. But that's interesting to hear that the voluntary markets actually have the quality control further ahead than these cap and trade markets. Um, what do you maybe attribute that to?
I attribute that to it coming on kind of fast and heavy when it hit. And then when the 45Q hit, everybody was trying to jump on board and try to figure out how do we get credits? How are we part of this? And there being so many different people launching credits from the European market of tree credits, from everybody's backyard and woods and anybody that owned a little piece of parcel, a lot of bad credits coming on the market so fast, and lack of time and knowledge to really be able to sit down and analyze, hey, what does it take to do this? How can we verify this? How can we make sure these are actually valid credits? How can we make sure it's permanently being stored and not released back into the atmosphere? I think it was a timing thing, and I'm not saying it won't work its way out in the future, and that's not something that'll happen, but currently, when we looked at it, everything we saw on the voluntary side, with the company's additions, which pretty much every large company had their own thresholds, had way more involved than what the regulated did.
And so we're talking about bad credits and good credits here. For someone who's looking to get into the carbon credit market, for someone who's looking to maybe purchase carbon credits for their company, what are some of the ways they can distinguish between bad credits and good credits? What are some accreditations, or what are some methodologies that they can look for if they're looking for high quality carbon credits?
So I would say the more accreditations, the better. Obviously, you look for a company that has at least one, if not more. We currently have three, and we're always seeking more as different companies come out. Different companies require different criteria. I would, look at who their accrediting body is, get on their website and sniff them out a little bit. If you're getting on a website, I'm not going to say any names here, but there's various ones that have this same protocol. If the same company is going to get on there and write you a plan to do carbon sequestration, and then they're going to validate that plan for you for another price over here, and then
Right.
they're going to take that and they're going to validate your quantities as your third party for another price over here, and they're offering a la carte like that.
Right.
Obviously you don't want to trust that validation from that company because they've done everything in house and there's really no validation there. They can't be all hats.
Yeah.
So you want a diverse sector of somebody that's validated your procedure, somebody that's validated your quantity, and then of course your ISO certifications that align with each and every one of those. So that's really what's important. And then if it's a company and you're in risk management, but you might not fully understand how the carbon credits work, go to somebody in your team, bring one of your scientists in, or some of your other team members in, and have them look at it. Just boil it down to common sense. A lot of this is really common sense when you look at it. I mean,
Mhm.
we've sniffed out mountain of them that way, just because a lot of our team does have common sense. I mean, if somebody's selling you a solar panel saying they're sequestering carbon, I mean, there's no way those actually have a huge carbon footprint to put them up. They may reduce the amount of electricity you need, but they're definitely not going to sequester carbon from the atmosphere and pull it down and permanently store it in the earth. And obviously, the same as
Right.
somebody throwing a bunch of trees up north that have been there for 200 years, somebody's not miraculously putting a toggle switch on them and cranking them up to where all of a sudden they're vacuuming carbon out of the atmosphere this year that they weren't doing last year. So just think about it for a little bit. If it doesn't make sense, it's probably not a good credit for you. That's how we've weeded out a lot of credits that people have brought to us, wanting help on getting their company certified, and who they go through a consultation. So really just stand back and look at it. Take the 10,000-foot view, and does this really make sense? And ask your colleagues.
Yeah. I mean, if someone is like in that example that you gave, if someone is acting basically as their own third party validator, that's probably that doesn't pass the smell test. So speaking on sort of the long term, the large scale vision, uh, I love this idea of proactively fighting against the let's say negative externalities of commerce, of industry, with technological solutions. And one of the objections that people bring into the mix is that things like direct air capture, or things like carbon sequestration, things are hard to scale. These things are difficult to scale. So how do you see uh, dynamic carbon credits? How do you see the vision scaling in order to counteract the growing externalities, the growing emissions from all of these industries, like, for example, AI, that they're going to be using more power than ever? How do you see dynamic carbon credit scaling for that future?
So that's a beautiful thing. What we are actually doing is we're actually using the plants to do it. So our scaling is actually incredibly easy for us to do because, as we know, farmers have been planting for hundreds of years. So that side of it's very easy and being able to scale up. And because of how much we're able to capture per acre, it doesn't take very much land while doing a lot more to be able to protect the environment at the same time, lower the sediment and washouts and all the different things that are happening with a lot of this land that doesn't have good things currently moving on it. Our product actually has been very successful, even in some of the worst contaminated lands, at sequestering carbon as well as PFAS and a lot of other nastier chemicals than carbon, methane digestion, CH4 conversion. And that's really what kind of sets us apart. We're able to go into some of the worst lands they can't use for anything, at the same time sequester carbon, clean them up for alternative uses, and secure and be able to protect a lot of the waterways from runoffs and wells and so on and so forth for generations and whatnot to come, to be able to help humanity and animals and nature and everything that we're all working on. So that's very advantageous that we don't require additional electricity or anything to be able to do that. As a matter of fact, in our biochar processing, the one that you would think we'd use electricity, and yes, we do use electricity. We mass produce a far greater amount of electricity than what we use. So
Oh, wow.
we're able to put that back on the grid and be able to bring them a very low rate of electricity, because we're, of course, already capturing carbon with it. So we're already starting out at a net negative in that equation, and be able to produce another great product at the same time as we're doing our biochar, as we're able to produce potash as well, which makes a lot more sustainable option for farmers, as well as a natural option for them to be able to use. So that's actually lowering carbon footprints for farmers to be able to put that on their fields as well. Being able to start out at
Yeah.
that side of the equation rather than a specific industrial application just for manufacturing that for them. So it's very scalable, and we made it that way on purpose because we wanted to make sure that as our company grows, that we were able to jump on and be able to keep up with demand.
That's very cool. And I'm particularly interested in the things you were saying about biochar and potash there. One of the questions that I wanted to ask there is, you mentioned that you generate more electricity than you consume in the the pyrolysis process, the creation of biochar. Could you explain how that works?
Yes. So as we are creating it, the heat that comes up as the byproduct from it, we're capturing that heat, and that heat's turning a turbine.
Wow,
So
that's
the
awesome.
turbine is generating the electricity.
That's awesome.
Yeah.
That is really cool. So this is not only sequestering carbon and then producing a viable product for the market, it's also generating electricity and putting it back into the grid. Um, as far, could you speak a little bit, because when we talk about protecting the environment and protecting the planet and preserving the things that we love about the environment, the focus is often on things like GHG emissions, and I think one of the other things that are a really big concern and sometimes gets overlooked is soil quality and the quantity of arable land on Earth. Could you talk a little bit about how biochar can help with that? I've done a little bit of research on my own about this, and I've seen how biochar can increase uh, water retention for soil, and it can increase the sort of microbiome in soil. That even it was used in the Amazon and Terra Preta. They managed to grow crops in the middle of the Amazon where the soil counterintuitively is famously not so fertile. So could you speak a little bit about what you see the potential for biochar in improving soil quality on Earth?
Yeah, no problem. So the biochar acts as kind of a mediator with the soil. It's been very effective, like you said, in the Amazon, where it's far too acidic for a lot of different things, all the way down to they've used it in a lot of different countries where stuff's way too sandy and they can't get anything to grow.
Mm.
So from one extreme to the other, it's kind of a mediator and puts it in the middle. Also, it does great with nitrogen and adding to it, and makes for a lot more viable option than some of the industry intense nitrogen production that they're doing, that they're currently utilizing to be able to put on the fields that the farmers are doing right now day to day. In addition to that, we've made various different sizes as well. So if there's a field that's really bad and they need to act on it before they plant it, we've got the fine granulars right down to the powders that they can broadcast on, and they can get a very fast absorption rate for their seeds and planting. Where if the fields are kind of in the middle side and they're closer, but they don't want to have to be able to put nitrogen, or they're looking for a more sustainable option as to what to apply for nitrogen, we can do the various size biochar that has the large all the way up to like 3-inch pieces, all the way down to there's about a 5 to 8% fine within that. And what that does is a slow breakdown for the farmers. So instead of going back through part of the way through the cycle, and then of course having the diesel and everything else that they've got added to that, the equipment wear and tear, and all the different carbon footprints that that brings to the table, they don't have to do that because they're still going to have that crop um, product that they put on there at the beginning, slowly breaking down and working through that. And by the time they're getting down closer to harvest, that it's finally fully broke down, and their largest pieces are still just slowly finishing up their feed cycles of the plants. So that's been very good to the farmers to be able to help them out with that, and save on resources as well, in addition to their carbon footprints.
That's really awesome. So I I want to kind of shift this now to what your vision of the future is. So I kind of started this channel with a focus on this idea of accelerating humanity's capabilities. I personally think that we're going to be multiplanetary, that we're going to continue to grow and follow the thermodynamic imperative that life set forth, and conquer as much of the universe as we can. And I know that seems like an ambitious sort of out there topic, but I'd like to get a feel for your sense of childlike wonder, what you kind of envision for the future of dynamic carbon credits and the future of the world, and how you see that sort of interplay, the big picture.
Yeah, so the big picture is we would really like to teach as many as possible on why this is the best option, why this is the most sustainable option, and really just be able to break down to the nuts and bolts of this and be able to let them really see how this works. It's really not that complicated. Our
Hmm.
breeding process was, but obviously we're through that point now. We've got our perfected plants at this point in our genetics. Be able to just really show them, hey, look, this is how it works. This is why this is a great option. This is why there's virtually no risk to this option.
Right.
And this is, the side effects of it. One of our side effects is we're adding 10 times as much oxygen to the air as trees, which obviously we all know.
Wow.
We all need to live, and does a wonderful thing for humanity. So being able to let them come out and see it. So what we do is we always have one field per year, and sometimes it's just one of our test fields. It might only be like a 5 or 10 acre field because we try to do it somewhat close to one of the main farms, and we might do a couple more of these throughout the United States. We currently just do it in Michigan, but where we can do field trips and they can come out and actually see and breathe and look at the monitors and see exactly what it's doing, what it's done to date, and where we're at. And it really wakes somebody up. Especially if somebody's flying in from out of state and you're picking them up at an airport. You're checking the CO2 where they're at the airport. You're checking it at the conference room when you get there before you're going through presentations, and you're checking it afterwards with everybody sitting in there breathing the oxygen, and of course raising the CO2 numbers out as everybody's discharging as they're breathing and consuming that oxygen from no doors being open and everybody being in there. And then
Wow.
all the way down to where you get out in the field, and not only is it sequestering the CO2, but it's releasing the oxygen in the air, and they're out there, they feel like they can breathe so much better already, and they're not even looking at the monitors. And
Wow.
by looking at them, and you pull out the handheld and remember where we were this morning at the airport and see where we are now. And it really, at that point, it's really hard for anybody to argue with it. And just seeing the plants do it and knowing you're not out there running a bunch of machines that
Hmm.
leak it back in there or anything. We're doing it the way it was meant to be done, and the way that nature has done this. We're letting nature basically be our big vacuum and putting it back into the earth where it came from. All this stuff came out of the earth at one point, but it's a matter of digesting it and putting it back in there properly, as opposed to, running a big hose in there and forcing it to go in there and causing earthquakes and so many of these different
Right.
dangerous things. And, solar panels that leak out a lot of chemicals when they're hit by um, different hailstorms. And, there's a lot of different risks that come with a lot of the different things that people are trying to do to make this world a better place. So, being able to do this without any of the risk was really, warming for us, and really gave us a good, idea of how we want the future to look. Anything that we can do, more nature, more plant-based, the better.
I love that. I love the idea of piggybacking off of billions of years of biological engineering, and we're taking that and we're running with it. And I wasn't aware of how measurable that difference in oxygen and CO2 was. I had no idea that you could go and measure that difference from one place to another in a place with a field of maybe of carbon sequestering, right, oxygen producing plants. That's really impressive. Um, so I don't have Zoom Premium yet, so we're running up on the edge of the meeting time. But I've really enjoyed this conversation. I've learned a lot. I think our listeners are going to learn a lot from it. Is there anything else maybe you'd like to say before we sign off here, Beau?
No, I think that was great. Thank you very much. I appreciate it.
Thank you so much, Beau. I really appreciate you coming on, and hope to talk to you again soon. The following interview is with Anna Jacobs, lead scientist at Dynamic Carbon Credits. The audio for the introduction got a little muddled, so it's going to start a few minutes into the conversation. Hope you enjoy.
As long as I'm not encroaching on my own proprietary information, I will give you as much information as I possibly can to educate you as well as anyone out there that wants to know how our company runs its business.
That's perfect. So, and I may ask some questions where you're like, if I answer that completely, then I may be giving up some proprietary information. So
I wouldn't do any of it. I would not.
You just let me know, hey,
Yeah.
I can't answer that part, or I can't answer this part. But I have a few questions, and I want to start with the plants that we're working with at Dynamic Carbon Credits. So I saw an interview with Beau where he mentioned that this plant is a blend of, and this is a public interview, so I hope this isn't encroaching on anything, that this is a blend of hemp, poison ivy, bamboo, and I think it was an acacia tree or something like that. And I was wondering if you could talk to me a little bit about the genetic modifications that we've made to this plant and why. Why do we have these genes from hemp and poison ivy and bamboo and acacia, if I'm correct? What is it about these, and what particular genes are we using, and how do those improve the carbon capture and sequestration profile of these plants?
Okay, let's start with the very beginning. The very beginning is the basis of this plant, the main basis of this plant, which is our proprietary. The base is hemp. What comes after hemp is all modifications to the plant. The reason that the plant was modified in different aspects genetically was to make it enhanced more so to be able to not only sequester carbon in large amounts, because the larger your root zone system, the more it sequesters carbon. The larger your plant is, it also sequesters carbon. So you want your plant to be tall, and you want it to be girthy, and you want your taproot to be a really, really strong taproot that gives you all the lateral root systems. Because not only do we sequester carbon, but I do methane digestion as well. It's still in the works, but I do methane digestion. And to have methane digestion, the only way to digest methane from the air is through the lateral roots of our proprietary plant. It can't be digested through the plant itself. And nitrous oxide reduction as well can only be performed through the lateral roots of our proprietary plant. That is why over time and over years of working, I genetically tried to modify it to the best of my ability and get different sources of plant species out there that can genetically be modified with the same enhancements. Instead of losing, I wanted to enhance this plant to make it stronger, girthier, have the ability to have an enormous lateral root zone, including its taproot. That's the main reason why we decided to go into the genetic modification of this plant.
Very cool. And one thing I notice about these plants, I'm no botanist, but at least 3 of them that I'm familiar with, hemp, poison ivy, and bamboo, are known to be, 1, very fast growers, and 2, pretty hardy, pretty adaptable in the kinds of climates and the kinds of soils they can grow on. Is that part of the consideration here?
Correct. That all factors in. Everything that we do has a scientific reasoning behind it, why we do what we do at Dynamic Carbon Credits.
Awesome. And so one of the things that I've come to understand about these plants is that part of the sequestration process involves the excretion of sugars into the soil. And in fact, there is a bacteria, genetically modified bacteria, if I'm correct, that is used in this process. Can you sort of walk me through how that works, and maybe what is the difference between the way these plants deposit sugar into the soil? Is that a common thing that plants do through the root structure?
That part of it is very common. What we do is the first part of when we do our prepping of our land, you always want to prep it with biochar. And I know we will get into the conversation of biochar.
Yes.
But biochar is it's high in carbon, and it's also high in silica, both which are great amendments for your soil in terms of carbon and silica, because you need it for your soil, as well as for the microbiome that's within the soil. It helps any bacteria that's in there naturally replicate itself faster. When you talked about sugars, that's where sugar comes in, because bacteria loves to feed off of that, because that's how they replicate themselves. And when they replicate themselves, then you have a naturally based land that's prepped and ready to go in terms of the bacteria, the pH of the soil, and there's a lot of things of why we do what we do in terms of how we do it.
So this bacteria, this microbiome in the soil is maybe analogous to the gut microbiome, where it manages the pH and
Bacteria.
it helps. Sorry.
Yes. I apologize. It's not only bacteria. I do a compost tea, so it's got bacteria and fungi as well. So it's
Okay.
not just bacteria. And I use it in two different time periods throughout the cycle of the plant. I use it during vegetation, and then I use it during the flowering stage as well. And yes, it does balance off the pH because our plant is more on the acidic side than it is the neutral side. And that's very important to understand as well because every plant grows differently in terms of their pH. That's why a
Yeah.
lot of people that have the inability to grow is probably because they haven't checked their soil first to see where they're at in terms of the nutrient levels, the pH levels, the humidity, there's a facet of variables that you have to go through before getting to prepping your land. And once your land is prepped, then you move forward from there.
And so the microbes in this case help manage those eventualities in the soil, right? The pH levels and stuff, and the biochar sort of provides them a growth medium. Is that correct?
Correct.
Okay. Speaking of biochar, one of the things that Beau mentioned, so I want to talk about the pyrolysis process for these plants. Could you describe a little bit about that pyrolysis process for?
Okay, so pyrolysis method is obviously pyrolysis is just a lack of oxygen. It's just a nice scientific term for a lack of oxygen. Everything that we do in our company is nature-based, including our direct air capture. We don't have machines on top of the plants or anything. This is all nature-based. And because the plant is genetically modified, it has the ability to sequester carbon in that quantity, and it has the ability to, like I said, digest methane and reduce nitrous oxide.
Okay, and the pyrolysis occurs in what? I mean, are these burned in sort of kilns or how does
It's an electric kiln, and then I can't go through our method because that's part of our proprietary.
Okay.
But the method that's done is as organic as it gets. There's no electricity involved. There's no turbine engines involved. It's just natural. And then the gases that are released, the gas that's released is recaptured.
Got it. So and those would be like the volatiles.
Some of them, correct.
Okay, and can you talk about what gets done with those volatiles?
It's reused.
It's reused. Okay. One of the uses that were mentioned here with these, and I want to know, because I'm not entirely clear, are these plants going into hempcrete? Is that sort of IP that DCC owns?
Okay, so when the hemp plant is done, it could be used for multiple things. It could be used for industrial use. It could be used for medicinal use. So it depends on what you're looking to do with your plant. With our plant, we have the ability to render the entire plant into biochar, which a lot of companies are very interested in biochar now in terms of the industrial side of things. Also, hempcrete, the owner of Dynamic Carbon Credits, Beau, he owns his own patent for hempcrete.
Okay.
And yeah, so he uses that as well. So what we have can be used depending on what company we're working with and what their trajectory for their project is. That's basically how my projects are. It all revolves around the company. Let's say a company comes in and says, hey, Anna, can you create a composition that's lighter than my composition for a piece of wood, let's say. And then I can create that. If I create that, we're using hemp instead of their product. And that offsets not only their carbon, they become carbon neutral, but we also offset their carbon and they become neutral, but we also utilize the plant from cradle to basically the grave, if you will, or cradle to cradle, and then back again into that same circle.
That's very cool. Awesome.
Yeah.
And you mentioned that there are several industrial uses for this biochar. So in addition to helping manage the moisture level and pH balance in soil, what are some of the applications of biochar that most excite you? You know, they don't have to be necessarily the biggest, but the ones that you think are the coolest.
I enjoy biochar because biochar can be used to create a mechanical strength for something that's like a construction a construction board, if you will, because I can't say who we're working with and what we're doing because I'm under an NDA.
Okay.
But the companies that I am working with, they give me an idea and they say, well, run with it. What can you do with it? Like one of the real cool things that I really like about biochar is that it has electroconductivity on its own. So it's like a copper wire,
Wow.
but it's these small little particles. That's amazing to me that such a simple form of a plant can give you electroconductivity.
That's really cool. So you can't talk much about how that electroconductivity is getting applied?
Yeah, no.
Okay, but it sounds very exciting.
Yeah, and then biochar too has a really, depending on your material and what you're using or what you're working on, has great adhesion to it as well.
Okay.
So enjoy that. And then also, if you think about it, biochar is not only used for industrial uses, it can be used for medicinal uses. You can put a little biochar in a capsule and you can test it. Let's say someone gets food poisoning and they want to get that out of their system. It's kind of like charcoal. It's got carbon in it. So once you ingest it, then it's clearing out whatever toxins you have in your gut.
That's very cool. And so,
yeah, so there's a lot of benefits to biochar.
So what are some of the I guess most popular applications of biochar currently, right? Not in development, but things that people are using it for right now.
Right now, it's soil amendment. I think a lot of places are using it for soil amendment.
Awesome. So
because it allows it to have aeration, just like you said, the pH. It helps with fertility of the soil. Biochar is just an amazing byproduct. If you think about it, you're creating something from like seed all the way through to the vegetative stage, to the flowering stage, to harvesting it.
Yeah.
And once you harvest the plant, then you have the ability to go into multiple ways, either making it into hempcrete, using it for medicinal purposes, or using it full throttle into biochar for industrial application. So it's got many uses to it.
Okay,
and
very cool.
This is just like the surface of what biochar can do. And I can send you through your email some information that gives you a list of what biochar can do.
Yeah, I would love to see that information.
Okay.
I know that there are historical. I'm sure you've heard of the terra preta in the Amazon and things like that, and it's got me thinking about how biochar and other such soil additives can help with the issues of soil depletion. But one of the things that I wonder about is how does it work in the long run? Do you keep applying biochar to the soil? Can you continue to do that indefinitely? Are there any studies on
you can
the
use
long-term
it,
effects?
you have to use it to a certain point, like everything in moderation. Because you don't want to put too much and then not allow the soil to actually amend itself. If it has too much of anything, really, it won't do well. So everything that's done in obviously proper measurement, proper percentages, it works very well.
Okay.
Yes.
So I want to move on a little bit to the carbon sequestration and carbon credits portion of the business. And one of the things that dynamic carbon credits prides itself on is that we use rigorous scientific methods to qualify our carbon credits, and likewise we use those in our consulting processes. So can you tell me a little bit about how we quantify the carbon captured by these plants, what kind of methods or third-party audits or whatever we're using, and how these compare to what we see in other carbon credit offers in the market?
Okay, well, to start off, when we started to do carbon sequestration, we wanted to find the best method of doing it in the most organic way, because we wanted to be carbon neutral and have zero carbon footprint. So that way we're setting the example from the very beginning.
Right.
we have different methodologies, and I have created a model. And I also like to use sensors. That's part of, that's part of, you could, if you will, that's part of technology, but it's not really technology because you're not using any electricity and you're not generating anything when you're using that. You're just using it to get real-time data. That way you can see what's going on in the soil instead of like having to, put physically trying to do it. Because when you test the soil physically, the numbers are a little different than when you're using a probe that's constantly within the soil or above the plant itself.
Okay, so there's some variation in those readings if you're not, and so you got to keep it constant.
Just keep on, you keep on, as a scientist, you just keep on tweaking things until you get it to where you want it to be, like the sweet spot of the scientific method, if you will.
Okay, so speaking of tweaking and pursuing more and better solutions, what can you and say whatever you can say. Obviously, there's some proprietary information in here, but what do you see in DCC's roadmap for scaling, for maybe improving or expanding into other solutions? What is your research telling you?
My research is telling me there is so much more we can do. Like we have just touched the surface of what carbon sequestration can be done with in terms of the plant, in terms of modifying the plant. There's always genetic things that you can do to modify it. I truly believe that we're just touching the surface of carbon sequestration and methane digestion and nitrous oxide reduction. And I believe that there are so much more applications that even myself as a scientist maybe haven't even discovered yet. And down the road, I do believe we will discover those problems with solutions for whatever company we're working with, be it industrial, whether it's an oil company, whether it's a electric company, whether it's a timber company. It could be any company. And I would love to be part of the solution to their problem.
I love the focus on solutions, because some of the sort of solutions that are proposed in the climate space and in the sustainability space, they often call for people to consume less or to scale back on growth. And those things are very big asks for people, and they're sometimes not practical or feasible or even impossible with some economic situations for people. So the solution-oriented approach is one that I'm a big fan of. And I think that what dynamic carbon credits is doing in partnering with these people whose industries emit and acting as sort of the offset for those industries is a great path forward. So how do you see your work offering a sort of pro-growth, pro-technology alternative to some of the more gloom and doom narratives? And in what ways do you think your technology helps humanity keep accelerating rather than pulling back or slowing down?
So with every company, depending on what the industry is, they give us their problem, and I create a substantial amount of research plus comparative studies and a project solution for them. And I also show them the numbers to where they can go from where they're at in terms of emission to carbon neutrality. And when they hear that we're carbon neutral and you have no carbon footprint, that excites them even more, because not only is there a solution, but now you've solved, but you've also networked with this company and you've gained friendships along the way, because there are some amazing scientists in some of these companies that I have learned a lot from over a time period.
I love that. I love the building of relationships and this working together to solve, because a lot of what these companies are doing that are major emitters that have these negative externalities, a lot of what they're doing is massively beneficial to humanity, whether in the energy and utility space or in the industrial production space. All of these, they're not doing these things for fun. They're doing them because they're meeting needs in the real world. And if what dynamic carbon credits can do is to offset the negative externalities, to decrease the harms while keeping the goods that these people do, then I think that's a net positive to the world. So I want to close here. I don't want to keep you for too long, but I want to kind of maybe have you sketch out, and this might be asking too much, but how do you see the future playing out? I know I asked you for the roadmap earlier, but how do you see in your imagination, right? You're a scientist, so you have a powerful imagination. I know that's something that a lot of people don't realize about science, but a lot of it is creative. And so I want to get a feel for how you imagine the future of dynamic carbon credits and the world in your most ambitious fantasies.
I imagine us as dynamic carbon credits being the true nature-based solution for a large amount of companies all across the globe, being in the United States or outside of the US. I imagine us being able to reduce the amount of emissions for lots of companies. And on a personal note, I'm a mom of 2 kids, 18 and 16. I'd like to see them inhale oxygen more so. And I know that our air isn't just oxygen, but I'd like to see them have cleaner air, cleaner water for the future. Like in the future, I would like to do, which we will be doing, is water treatments. Wow. For large companies. We have the ability to do water treatments as well. Why not clean up the water, clean up the soil, clean up the earth, and give it to them on a platter where they don't have to do the work? We are more than happy to do the work and the solution for them. And all they have to do is purchase the carbon credits that's transparent, that is made well, that is backed up by third validation parties. And we are proud as a company, and I hope to see myself grow into this company until I retire or past that.
Well, that's a beautiful and inspiring vision, and I think the work you're doing puts you on a course for it. So I really appreciate your time, Anna, and I really appreciate the knowledge that you shared. And of course, I appreciate the work you're doing at Dynamic Carbon Credits. It's really changing the world.
Thank you very much. I appreciate your time, Juan, and thank you for this interview. And if there's any information that I have not spoken on that I didn't touch on at all through this interview, just send me an email with the questions and I'll be more than happy to send my answers over.
Absolutely. Thank you, Anna.
You're very welcome. Have a wonderful day and have a great weekend.
You too. Merry Christmas.
Merry
Bye.
Christmas.
Happy New Year. Bye.
Happy New Year to you. Bye-bye.
And now, please welcome Emily Dakoske, Business Executive at Dynamic Carbon Credits. All right, so welcome, Emily. Thank you. Emily is an executive at Dynamic Carbon Credits, and she's actually the first person I met who told me about Dynamic Carbon Credits. And so thank you for joining me, Emily. I guess I want to start with, how do you position Dynamic Carbon Credits against other carbon offsets or climate tech solutions in the voluntary market? So what makes the approach stand out in terms of both credibility and long-term viability?
Yes, Juan, that's a great question. And thank you so much for having me here today. Just in regards to your question, when I look at the offering that Dynamic Carbon Credits offers, we're considered high value. We're a high value carbon credit. And then also our ability to scale makes us stand out from other technologies. Just in regards to high quality, the different forms of additionality that we offer is superior to other solutions. And then also the data that we're able to capture and provide buyers is trackable and then also very compelling. Okay, so that in regards to scalability, our solution is deployable in many different climates and then has a short, succinct growth cycle, which clients can leverage to take action now, but then not in a year lead time, which is offered by so many other different solutions.
Okay, that's really cool. And when you say, so why is it that Dynamic Carbon Credits allows people to take action now? and other solutions don't? What is
Sure.
the difference there?
Sure. We currently have carbon credits available now, which is really important. But then also the fact that our solution is plant-based. It's a direct air capture agricultural solution. So the upfront infrastructure, we're not building facilities. We're not building or trying to purchase manufacturing space, which can be time consuming and also really costly. We're working with US based farmers to deploy our local solutions in farming
Very cool.
communities. So it's something that companies can take action on today.
Very cool. And as dynamic carbon credits expands, where do you see the biggest opportunities for growth? Are you looking at more agriculture, construction, energy? What are some of the key partnerships and collaborations you think are going to be crucial to scaling dynamic carbon credits as a solution?
Yeah, that's a great question. And I honestly think about that all the time when interacting with different clients. Working with large scale corporations is where dynamic carbon credits can excel. And then also working with different governments is where we can lean in, leverage our experience, leverage the technology. And for example, the US government has many direct air capture programs. They're looking for solutions. So we can lean into those types of different initiatives to really create that big impact.
And what are some of the hurdles that DCC is going to face in bringing these, all of these different business models together into one seamless business model and scaling them with these potential customers?
Sure. From my opinion, when working with different clients, it's the educational piece. It's working with buyers, working with the choice of sustainability and choosing sustainable programs and initiatives and creating those is a cross-functional choice within a business. And it's getting everyone to see the vision, understand the value proposition, and move forward with the solution. So that educational piece is still a big aspect when working with clients. So I don't necessarily see it as an obstacle. You just have to be able to have the time and also the buy-in to complete that step so everyone has awareness to be able to see the value and the long-term values.
Okay, awesome. And where do you see dynamic carbon credits in 5 years? So what are the biggest milestones on your roadmap?
Sure. I see it being a very common direct air capture solution just because we don't require much electricity to generate our solution. We need to look at agricultural solutions to decrease greenhouse gases. And I feel like as we are learning about the best solutions in the direct air capture space and saying, hey, what works, what doesn't, what is deployable, how much capital is needed for different solutions, I think that's the journey that people are going through, particularly in the US. And I do feel that the solutions that require no electricity or minimal electricity are really going to be the standouts in the long run.
I love the idea of not relying on electricity for this solution for this air capture technology.
Yes.
It's really exciting. All right, and I guess how do you see, because sometimes in agriculture and construction in particular, adopting new technologies can face some resistance. So how is DCC engaging with local communities, with farmers and builders and stuff? How are we leveraging those connections to demonstrate the financial and ecological benefits, if we are?
Yes. Conversations is how we're doing that at this point. Zoom conversations, in-person conversations, working on the political side. It really takes, to deploy this type of technology effectively, it really does take an army. And I do think that's what sustainability professionals have been facing for years, if not decades, because it's such a cross-functional choice. So dynamic carbon credits at this point is, we walk the walk and we talk the talk. It does take that education, and you really need to talk to anybody and everybody about your solution.
Awesome. I love that response. Okay, Emily, those are all the questions I had prepared for you.
That's it.
But, I really appreciate that. I really appreciate your time. Thank you.
Absolutely. Thank you so much, Juan.
All right. And can we just stay on to talk about that?
Absolutely.